Hello and welcome to the MFG Advocate. I'm Penny Brown. Additive manufacturing is the industrial version of 3D printing, and here at IMTS, it's a technology with a growing presence. Today, we're here to talk with Chris Schuppe of GE Additive about some of the latest developments with this great technology. How are you today, Chris?
I'm doing well, thanks Penny, thanks for having me.
Excellent. So I heard this is your first time at IMTS. What do you think that says about additive manufacturing?
Well, it says we probably need to be more present in this show in the future. For me personally, I missed it the last 2 years for personal reasons, actually working in the additive space, trying to develop our technologies, but I'm really excited to be here this year, and it's an amazing show with lots of technology and certainly additive a key part of that.
So what's kind of the current status of the adoption for this technology in an industrial setting?
Yeah, I think it's an interesting question. You look, from my perspective, additive has grown a lot in the last 5 to 10 years, but if you look at global manufacturing as an industry, it's about a $15 trillion a year business. Additive, depending on which report you believe, is somewhere in the range of 3 to 5 billion. So it's a much smaller industry compared to the big manufacturing industry, but that's growing at a rate of 30 to 40% per year. So we're suddenly becoming relevant and at least part of the conversation where 4 or 5 years ago it was considered, everyone called it rapid prototyping, and there was no real mention of industrial applications. And part of why GE is getting into this space is really to drive that conversation is, how do we make this into a production process, not just a laboratory or a rapid prototyping process.
Sure. What do you think are some of kind of the barriers to it really being a production technology at this point?
I think I talk about 3 to 5 main things, but 2 of them would probably surprise you. One is just basic knowledge, where you'd say people just don't understand the technology, and there's a little bit of a unknown there where, because I don't understand it, I don't like it. So we're, part of our GE Adworks offering is really how do we help educate customers to get through that. The second one you probably wouldn't guess is company culture, where a lot of companies have become really, really good at specific conventional manufacturing techniques, where if you go in and you say, hey, it's great that you have 100 CNC machines here, but we want to 3D print this part, they say, no, I have 100 CNC machines, why do I care about 3D printing? So I think those are 2 that are frankly barriers that will take time to overcome. It's an education process, and really finding wins in those industries will help us get over that hump. I think other things you can see, and you're starting to see this from several machine manufacturers, is how do you make the process more automated, where it's not just, I plug in a CAD program or a slice file into the machine, and then I have to come and manually evacuate powder, I have to come and manually remove build plates and things like that. You're starting to see some automation around the process that will start to penetrate lower cost marketplaces like automotive and industrial applications, where today the majority of the adoption's in the orthopedic and aerospace environment.
Yeah, it was actually what I was going to ask you. What are sort of the key applications for additive right now?
Yeah, I mean, right now there's, the biggest are probably orthopedics and aerospace. So you see a lot of orthopedics in the sense of medical implants, that, hip implants, knee implants. There are companies who have anywhere from 20 to 100 machines that are 3D printing, orthopedic implants every day, 24 hours a day, 365 days a year. Some of those will produce over 1 million implants in the next year or so. So really, a lot of people don't know that. And I heard a stat recently that by 2020, roughly about 2% of humans will have some form of 3D printed technology in them, whether that's braces or implants or whatever. So it's really starting to penetrate the market in that space. Aerospace certainly is a big area of adoption. Things like satellites, jet engines, airplanes, you're starting to see across the board applications develop. The big barrier there, I would say, still is material properties. A lot of people are afraid of material properties or consistency of material properties. Mm-hmm. So we've tried to help in that space as well.
Have you found that maybe like parts qualification is an issue with additive manufacturing as well?
Yeah, for sure. I mean, I think today, if you look at the industry, there's just now, in aerospace specifically, that just now there are qualification standards that are coming out from a few agencies that are really targeted at how do we do this consistently across every entity and not just specific to one company. GE, when we went and certified the LEAP fuel nozzle, which is one of the more famous early 3D printed metal applications, it was very much a one-off type of process with the FAA where we said, this is how we're going to do it for GE for 3D printing. It wasn't a industry-wide specification. I think you're seeing momentum building towards more industry-wide applications and specifications that will hopefully ease the entry to the marketplace.
Right, I'm seeing like NASA and some of the sort of, Department of Defense, they're starting to really use NASA, more of those things.
Absolutely, NASA, DoD, SAE, they're all starting to come out with their own standards around this process. And, frankly, we're sitting on a lot of those committees and trying to help, influence the right discussions in those conversations. Legacy coming from GE Aviation, safety is always one of the first words out of my mouth. So, I want to make sure we're printing safe parts and that they're the right. So we're trying to influence that conversation to make sure we're setting that specification level at the right kind of safety bar.
Sure. So tell us a little bit about GE Adworks and what you do.
Sure. Yeah. So a bit of background, maybe before I directly answer your question, is I started my kind of journey into additive way back in university. Simple plastic 3D printing, and I was just captivated by the kind of ease of the technology and how kind of interactive it was for a student to be able to experience, wow, I designed something and then it's sitting on the table very shortly after. I went and I worked in automotive for about 6 years and then came to GE Aviation, and when I worked quite a few different roles, really didn't get back into 3D printing until the late 2000s, but started working on rapid prototyping of parts because we didn't have a part ready for the engine, so let's go print one that we can use for a test vehicle. It wasn't really until 2011, 2012 timeframe where we started developing production applications, and myself along with my team, a lot of the folks came from either aviation or other GE businesses where they were doing the same, and frankly we failed a lot. We learned a lot of lessons. We found ways to do it wrong, and then ultimately we found ways to do it right. And part of our value proposition as Adworks is really how do we help customers do it right the first time. The technology is already a little bit, like I said earlier, a little bit mystical to people, or they don't fully understand it. So how do we simplify it for them in terms of training, but also how do we help really give them our expertise at every step of the way so that they get from, hey, I'm curious about additive, to I'm in a production application as quickly and as efficiently as possible. Mm-hmm. And really every step of that journey assisted by our GE additive expertise. And that's really what Adworks is think of it as almost like additive acceleration. How do I help a customer get from an idea to production as quickly as possible?
What types of customers are you typically serving?
So typically, larger customers, companies that want to do things at scale, big companies that you would have heard of, certainly, for the most part. But, it's interesting, a lot of aerospace, a lot of industrial applications, some orthopedics. What's funny, though, is we've actually found some applications that we never imagined we would find. Food processing equipment, for example. Mm-hmm. I knew nothing about food processing equipment until 2 or 3 months ago, and then we had a customer who came to us and said, we've heard about this 3D printing thing, what should we do? And we actually helped them get from a conversation of, we're just curious, to now they have a production application that they're going to take, and it's actually changing the way that they process food in a better way, right?
Yeah.
Which is, I think that's the magic of what the additive technology brings, that it really can influence every industry, and we're just starting to peel away at that onion right now.
So you mentioned you are working with a lot of larger companies, and obviously GE itself is a very large company. So what would you suggest maybe for a smaller firm that wants to explore the possibilities of additive?
I think there's a lot of ways to go about that. I mean, GE, for example, has, we have free webinars where people can come and learn the basics around what is additive, how can I apply it to my business, how do I develop a business case. We give some of that away for free because we want to encourage that grassroots type of learning. Our CEC centers are a place where you can go and you can see the process in person. You can learn the basics. When you think about sort of the advanced, beyond just hey, I'm curious and I want to learn some basics. There are a lot of service bureaus out there, and we are suppliers to a lot of those service bureaus that, if you want to go print one part, they're happy to do that for you at a relatively reasonable cost. So you can start to learn incrementally very quickly. The other place I would say is university partnerships. A lot of the universities are really just starting to get into curricula now where they're saying, wow, this additive manufacturing thing, they call it additive manufacturing, not necessarily additive broadly. And they're just starting to develop curriculum. And what's interesting is I've been to probably 30 different universities in the last year, and every one of them has that discipline in a different department within their university. So some it's in mechanical engineering, some it's in the materials space, some it's in the industrial engineering, and some it's in the business school, and it's all over the place. And they're actually having arguments about where does it really belong and how do they integrate that correctly. And my answer to them is it's all of those, right? It's the join of all of those disciplines together. And if you don't have that, then you're not necessarily successful.
Yeah, that really speaks to how exciting the technology is.
Absolutely.
So speaking of which, what do you find most exciting about this technology?
Yeah, I mean, for me personally, it's a technology that I think it's going to change the way that we really make everything. And that may sound, I'm a bit of an additive zealot, right? But, frankly, if I look at how we made a jet engine 5 years ago, today it's radically different because of 3D printing. Now that's a jet engine, very specific application, but when you start looking at other industries, like shoes is a good example today, and GE is not heavily participating in this, but we're invested in a company called Carbon 3D that they're helping to 3D print shoes.
Right.
You look at medical implants is another one where, you just go on any additive website and you go read about additive technology on a weekly basis. You're going to see things in healthcare, commercial products, consumer products, future of flight, space travel. It's going to be pervasive in all aspects. And I think the exciting thing for me is how do we help create that and really shape the future.
Right. And actually, I know you're speaking here at the Additive Conference, which is that's another huge development, just that we have an Additive Conference here at IMTS.
Right.
So what are you going to be telling the audience about there?
I'm really talking about what we've been talking about a little bit is, 5-6 years ago, everyone called 3D printing or additive manufacturing or additive, they called it rapid prototyping. That I think some of the shows were even called like rapid, right? Mm-hmm. Rapid came from rapid prototyping. I'm really talking about that transformation from additive as a prototyping technology to how does additive become a production technology, and what does it take? What are some of the pitfalls in between there, and some of the changes that really have to happen at company leadership levels and at the the engineering level to ultimately make that advance into the future. So hopefully getting people excited about when does additive become real for them, not just a conversation about making rapid prototypes.
Right. Well, it's really exciting to see all of these developments, just here at the show. It's speaking a lot to how the technology is maturing.
Yeah, no, it's great, and I think, like you mentioned, I think 3-4 years ago at IMTS, you probably had 1 or 2 additive machines in the entire facility, and now there's an entire wing dedicated to it. There's an entire separate show dedicated to it, and you just look at that growth and think what it's going to look like in 10 years, and I think we'll all be hopefully pleasantly surprised that it's half the conversation in 10 years.
For sure. Well, thank you so much for your time today, Chris.
Thank you very much, Penny. It was a pleasure to talk to you, and I'm excited about additive, so it's always fun to talk about it.
Thank you.
Thank you.
This has been Penny Brown for the MFG Advocate.